Hey everyone, Dan Rohan here with a quick tip on how you can use Kentik to quickly find parts of your AWS network that are misrouting internal traffic over the internet. Let's start by talking about why we'd actually want to find this traffic in the first place, and there's a bunch of good reasons. As you probably already know, every cloud instance in AWS can be configured with both private and public IP addresses. Private addresses are used for internal communication, while public addresses are used for external communications with outside services. Sometimes, and especially when control over networking functions is extended to service teams, public addresses end up getting used for internal communication, flows between instances. And this isn't good for several reasons. First, anytime any network traffic from within a VPC is directed towards a public address, it means that traffic leaves AWS momentarily, usually before hairpinning back into AWS. And while it's likely that this kind of traffic will never actually leave the AWS network, there's also no guarantee that this traffic won't be routed over commercial internet provider networks. And if that happens, we might see higher latency between the source and the destination of that traffic. More concerning is that this actually could present a security threat, because when that traffic does go over the public internet, it's no longer by definition private. And so it can be inspected by anyone along the path. But it's also likely that organizations have set up specific monitoring points where traffic in and out of the organization is inspected. And so-called rogue internet gateways can actually create blind spots in that monitoring strategy. Probably the biggest reasons that we see our customers caring about this is cost. Traffic goes over an internet gateway and then it's metered between 5 and 9 cents per gigabyte. But if this is internal traffic and it's routed locally, it can be free. Or if it's routed over a VPC peering session or a transit gateway, the per gigabyte cost is more like 2 cents per gigabyte. And at scale, these kinds of cost savings can be very compelling. So let's go ahead and see how we can find this traffic so we can shut it down. Okay, so the first thing we're going to do is go into our Data Explorer here and set up a query. I'll choose AWS as my data source. And then I'm going to select some dimensions that will help us make sense of our traffic better. First one is going to be VPC. And so I'll choose the source and destination VPC, but I'm also going to add in gateway. So I'm going to choose gateway type and gateway ID. And then I'm just going to drag this down here to create a flow from source to destination and hit save. Okay, so once we've got our results, we can see we've got a few different VPCs talking to a few other VPCs, sending traffic over a variety of different types of gateway. We see some local gateways. We see a transit gateway ferrying traffic between two different VPCs, but then we also see traffic from one VPC to another going over an internet gateway. Not good. So the way that we're going to look into this is click on this hamburger menu here and say include internet gateway type and apply those filters. But then I'm going to come here into the query and just make this a little bit better by adding one more filter. What I want to do is make sure that we're only looking at traffic that goes over an internet gateway type, but is destined for internal. So to do that, I'm going to choose something called the traffic profile. The traffic profile dimension is super useful if you haven't played with it before. It allows you to take a look at all your traffic and slice by the traffic profile. In other words, how is it actually exiting your network, entering your network, and so on. So we can see here we can choose multi-cloud from inside your data center to your cloud. But in this case, I want cloud internal. And I'm just going to make sure that we're going to take a look at both of those and hit save. Great. So now we've just got the flows that are going over the internet, but staying within the cloud. And to make sense of what's actually happening here, I'm going to come back and add a few more dimensions. So I'm going to add instance name, source and dest instance name, and then also IP address, because I think I've got a suspicion as what's actually happening here. Clicking save, we're going to automatically rerun that query. All right, so we got our latest results back, and we can see pretty easily that this was caused by someone who had deployed a configuration maybe to these VMs to send or receive data using a public IP address. So we could definitely make this better, set up some internal routing, and save some money. That's all I wanted to show you today. Please reach out and let us know if you have any questions or comments. We'd certainly love to hear from you. If you'd like to see for yourself how you can use Kentik to achieve network observability, just head over to kentik.com and spin up a free trial. It'll only take you a few minutes to get started, and you're going to see your network with more clarity and depth than you've ever seen before.